Thanks for joining this session. Today I'm going to talk about retrieval augmented generation, and the right way of looking at is basically a generation augmented by retrieval. That's how one can easily comprehend this technical term called RAG or retrieval augmented generation. In this series, I've got 5 sessions, like I was talking earlier. We have to look at AI or solutioning using Gen AI in a holistic way. And the idea of this series essentially is going to cover 5 different aspects or 5 different topics. The first two are focused on RAG. RAG is an important cognitive architecture pattern, and that's why we have 2 sessions. But there are other things which are really important, which are kind of becoming very mainstream: small level language models, fine tuning of models. And I also have a practical implementation of Gen AI for ETL and visualization. That would be one of the topic. So the approach is simple. We'll discuss concepts, technology, and then demonstrate through the examples. These sessions are kept purposely at high level. I don't want to overload you with technical jargon or coding things, although I'll show you some. But the idea is to make sure that we create an understanding at a high level first, and then we can later on go in detail if required. So format, concept, demo, questions, around 45 minutes that we are going to spend. Now, what is important to call out here is, like I just mentioned, these sessions are very conceptual. The idea is to really generate confidence in anything which we're going to discuss. I do it purposely, doing things hands-on, just to be sure that whatever I'm talking is feasible and it is implementable. And we can take it to the next level if somebody is looking to go into programming detail or solutioning detail. I am an Azure architect, so I use Azure platform to deploy some of these things, but by no means this is related to Azure platform only. So whatever I'm doing is agnostic to model and platform providers. Model providers could be Meta or OpenAI or Google. So these are the companies who build models, and platform companies AWS, Azure, GCP, IBM. So whatever I'm discussing is based on mostly open source technologies. You can see these icons, almost all of them are open source. And that gives ability for all of us to really implement these patterns in whatever platform and model they think we think is appropriate. So that's important call out. I've created a LinkedIn group essentially to enable a discourse on AI. We can share knowledge and learn from each other. If you think you'd like to contribute, ask question, please feel free to join if not done already. So I had 2 more series in the past. One was in December and April. The first was basically talking about the core concepts. April 2024 series was focused on agentic AI, and please note, agentic AI is going to really catch up very fast this year or next year. This is basically a layer above your core Gen AI, where it can actually perform a lot of things using orchestration. So feel free to go through those recordings. Let's start today's session. We have all worked on ChatGPT, Bard from Gemini, Google. Gemini, it used to be Bard first, which basically enables a back and forth communication. But Gen AI has evolved. It has evolved to a pattern called RAG. That is the focus today. And co-pilots and agents and assistants. You hear all these terms, they basically mean the same. They talk about a layer on the top of GenAI models to perform some orchestration, bring in some automation. We have covered that, so we'll focus on track. And going forward, you'll probably see AGI coming sometime in future, which can really do a lot of things at human level. Now, if we are using GenAI, first thing we have to really understand how these models are built and what are the limitations these models have. Now, if you have worked on GenAI models, you probably encountered a situation where the response is made up response by the model. It will just generate things which may not be true or may not be grounded. And that's a big problem with language models because they have been trained on public data and they're expected to give an answer sometimes without any basis. For enterprises where we people operate, explainability is very important. So we would like to know why the answer is what and what's the basis of it, which is an important aspect for GenAI applications in the enterprise world, where we really want to validate things are done based on some real facts or data. Language models are trained on diverse set of data, mostly web content, social media, books, and they have general knowledge. So they are good for most of the cases, but perfect for nothing. And they have a cutoff date, which means they are trained on a data. Anything happens after that, these GenAI models do not have the knowledge about it. And the most important thing is they do not have access to the private data, which means if you really want to use GenAI in enterprise scenarios where a lot of data is private to the organization and it is important, the data from customer relationship management, order management, all that is important when we are talking about building application that leverages GenAI models. So we definitely need some capabilities that allows us to add corporate data or domain knowledge that organizations have built over a period of time. So let's look at through a demo, what do I mean by limitations? I would have a combination of demo and concept just to make it more interactive. I will take questions at the end just to make sure that I can complete my agenda. So let's say when we ask this model, who is Bill Gates? So you'll get a good formed answer. Bill Gates is a famous personality. The knowledge about Bill Gates is available across different data sources and we get a good response. Now, how about if I ask, who is Tarun Sharma? Let's see what the model say. I'm using ChatGPT purposely so that you can try at your end. So there are so many Tarun Sharmas and model has no clue. It needs more context to answer it. Tarun Sharma is not famous, so that's why you really don't get the kind of answer that you may sometimes expect. Now, how do we fix that limitation? Now, there are three ways you can do that, and you can provide a context where you provide some input along with your prompt and you get a response. It's called in context learning. Use retrieval augmented generation, which is the topic for today, where you provide some mechanism for model to refer a knowledge base or a knowledge store. We'll see how it can be done. Or since the models have been trained on a public data, you can add your private data by fine tuning and you will get the response. And we'll see RAG and fine tuning as part of this series. Prompt engineering is very simple. I won't really cover that. Now let's understand what is retrieval augmented generation, or the way I put it, generation augmented by retrieval. That makes it easy. So what you're doing, you are using a generation AI or Gen AI, which is augmented by retrieving something and passed that as a context along with the prompt to the model to get a response. So this takes care of most of the limitation that we have discussed in Gen AI models, and it also provides you a great context for the organization. Now, before we go there, I just like to talk about things like tokens. So tokens are the input and the output that model uses, and a token is around 4 characters, and the token is calculated for the prompt and context before Gen AI model generates the response, and the response also is basically in terms of token. So it's basically a measure of computational resources. A model has to do something, and it has to really take input, process it, and then generate an output. So that's basically the resources that the model consumes: compute, memory, storage, and models have a limit. So although there are models like model Gemini 1.5, it talks about a million token, but definitely every model has a limit. And the cost is associated with the token. If you are basically using a model hosted on AWS or GCP or Azure, it takes certain cost, which is the input and output, which is in 1,000 token to run your model. Just be mindful. And what it does basically, the tokenization is a process which is done prior for model to really start generating the response. Now let's look at what is a tokenizer. So you can actually see how models basically tokenize before processing it. See, for example, if I put a phrase, the quick brown fox jumps over the lazy dog, it has 44 characters and 10 tokens. So you would find there's a difference in terms of number of words in the token, and that is what I've explained in the previous slide. If you take another example, so there are 3 words, but there are 6 tokens, and the way tokenization done, they basically break up a word into a subword. The idea is that each word becomes, an independent parameter for model to work. Just for understanding. Now let's get down to the core topic. What is RAG? So what you see here is basically a process flow of a RAG implementation, and let's start from the top left. So what is done in RAG? You basically provide some documents. It could be structured, unstructured, or semi-structured set. It could be PDF document, Excel, PowerPoint. And as part of the ingestion or indexing process, this document is broken into chunks just to make it more manageable. And these chunks are embedded. And this embedded data, and don't worry, I'll show you each part so that it is clear, is stored in a vector database. Now, vector database provides you the ability to do a semantic search, and that makes it really useful for your question to be grounded with some context. Okay, now let's look at the second part. When you ask a question, the question is embedded, and think of this vector database like a Google search, and the contents are there in the embedded form, and I'll explain what is embedding. So the question is also embedded, and you perform a similarity search of the embedded data in the vector database and the embedding of the question. So the prompt is embedded, and that is provided as a search criteria in the vector database to pull out the relevant chunks. Now, why we have to chunk? Because every model has a token limitation, so you need to really select only that set of data or a chunk which has the content that you are looking for, and also it overcomes the limitation of the context window. And then after the search is performed, the prompt is augmented by the search result, which is part of the retrieval. So you basically retrieve the relevant information, augment it with the prompt to get a grounded answer. That's how it works. And let's take one part at a time. So let's understand what is embedding. So embedding is a way where you represent the information, it could be of any type or modality, in the vector space. Think of it that you have a body of text or a corpus. When you embed it, it really creates a n-dimensional, which is for OpenAI is 1536 vectors which are created, which represents that content in this n-dimensional space. So you use some embedding model, data is converted into vectors, vectors are stored in the database, vector database, and the query is converted into vector embeddings so that you can perform. So it's very similar to retrieving data from a database, a relational database. You provide a key and you get the result. So here it is the embedding of the question or the prompt that is used to query the relevant. You would not find in like a relational database an existmat. What you get is a semantically nearest form. For example, if you see on the right, you can see how man and woman are represented and they are close to each other, and king and queen which are represented differently. So this is basically a machine learning technology that basically helps to perform a similarity search, because exact search is not possible like we do in our online systems. So let's see what all types of object can be embedded. You can actually virtually embed any type of objects, and let's see how through a demo how that can be done. So what I have here, an implementation. Before that, I'll just take a simple example to illustrate something that will explain why we need. So let's ask let's ask who is Bill Gates again. Sorry. We know we got the answer, we'll get the same answer. Now suppose I want to ground my response for who is Tarun, for example. I won't get the response because the model has not been trained on something, but I can always provide some grounding data. Let me just provide a PDF which has around 60-70 line, and then ask who is Tarun now. Now you've seen what was the response earlier, and let's see what is the response now. Now it gave the exact details about Tarun. Tarun is an Azure cloud architect. He works in IBM based in Sydney. Now see the difference in the response, and how did the same model, I'm using GPT 4.0 most likely, and see the difference in the response. And now let's ask, who is Bill Gates? So, oh, I didn't press. Oh, free limit, that's fine. But you got the point, and I'll explain that. You need to be, okay, I've got other models. But anyway, I've got an enterprise demo. So you get the point. Now, what has happened after I supplied this context? This is a PDF document which has some details about me and other folks who are working with me. And now the model has provided the right answer. So this is the private data or organization data that I can supply. And it is also providing me the source or the reference from which it has generated the data. Now let's look at it in an enterprise way. This is just for your own test if you want to do. So what I have, a RAG implementation. So I've got a storage account which has a blob container, and I've got that same file here. I require a search. So if you remember, we talked about vector index or vector database. So what you require, something like a search service, could be any service, and later on I can actually show you. You can use other models for doing the same. So I've got a search service, and I actually use that before this call to ingest a data, and I'll show you how the embedding looks. So I've indexed that after chunking. So since it was a small document, it just created one chunk. And what it has is basically an embedding in it. Okay. How the embedding looks like, I'll give you a better example. So let's look at this, and I'll just run it again. So there is a model called EDA on OpenAI that I use, and you provide a text to be embedded. It could be anything. I'm just putting this text as an example. And when you do the embedding, it's just one line. Typically, you would have a larger chunk to be embedded. And it has created the embedding, which is, you can actually see there are 1536 vectors, which are nothing but numbers, representing this text in an n-dimensional space. And that's how the embedding is done and a vector database is created. Now, once you do that, you would like to do some prompting on the top of it. So like I said, in that embedding, you have something called a cosine similarity, which is a method used in machine learning and natural language processing to measure the similarity between two vectors. So what you do, you vectorize your content after splitting them into chunks. You want to do it because you just want to take those chunks which has the relevant data. You may have to rank them. That is all done internally. And then when we do this query, your prompt embedded to be used as a search to pull out the relevant content from your knowledge store, and that is fed into the model to get the grounded response. That is what exactly I've done in ChatGPT, where I uploaded a file. Behind the scene, what it did, that it actually created chunks. It was a small document, probably it had 1 or 2 chunks only, then stored it in a vector database after embedding it or vectorizing it. And when I asked who is Tarun, the second time, it vectorized that after embedding and searched that vector database and then pulled out the relevant information to generate that correct answer, which was grounded on facts. Okay, so that's how it is done. The example that I've shown is this. I've used, and I'll show you how you can easily do that. So you have data sources, could be structured, unstructured, no, semi-structured. You basically chunk it, embed it, store in a vector database. When a user query is performed, you vectorize the prompt, perform a query, generate the content, which is prompt plus context, and get a response back to. So that is basically the RAG implementation. So let's see how it can be done if you want to do that. And mind it is no different. It is not related to any provider. Let me just, because I'm sharing screen, so I'm having issue. Make So how you have to, if you have to do it, what you have to do, so you need a storage, and I'll show you how this can be done very easily. Sorry, struggling with multiple windows. So let's say you are using service like Azure OpenAI. So there is something called a bring your own data. You select the data source. You can actually upload a file. You can use Azure Blob Storage. You need a container from where it will fetch the record. You need an Azure AI Search, which will perform chunking, embedding, and provide you a vector database. So so this is the search. I give an index name because I have to create an index. Okay. How frequently you want to index, if your data sources are changing, if you're basically having contents coming from other enterprise sources that keeps on changing, so you can actually run it hourly, daily, or once. You choose either you want to do a keyword search or a vector search. In this case, we are choosing to do vector search because that is more performant. You use an embedding model. Then what type of search you want to do. So hybrid and semantic, and that's it. Okay, so it will then create something like this. So I've just done it before this session. Now I ask again, who is, okay, this time let's ask. Now what I'm going to do, so this is a RAG implementation. It is providing me the correct answer. It is also providing me the chunk which I can refer. So like I mentioned, so this was the data that I've used. For enterprises, it is important to know what you are getting as a response is correct or not. And that is very important. Now it's very straightforward. There are numerous ways you can implement. You can implement RAG in memory. You can implement using other models for embedding and LLMs. So let's go back to our, I think we've covered most of this.